Hi everyone, welcome to this new lecture of hydraulic machines. In this lecture, we'll discuss a concept regarding characteristic curve of centrifugal pump. So in the characteristic curves of a centrifugal pump, uh, the plots will be plotted by conducting number of tests on the centrifugal pump. So these kind of plots will be identified by conducting number of tests. That means number of runs will be done on the number of tests or experiments will be conducted on the centrifugal pump. So from that result, this kind of graphs or curves can be plotted. Okay, number of tests will be conducted on centrifugal pump, and from that, what are the results are coming out? From that result, we can plot this kind of graphs. Okay, so why these characteristic curves are required or why it is important? The thing is, from this kind of curves or from the characteristic curves, okay, to predict or to understand or to identify the behavior, okay, to understand or to predict the behavior, and another thing is there, that is behavior and performance of the pump. So these two things are very important for the any kind of pump. So to understand the behavior and performance of centrifugal pump. So when the pump is working at different flow rate, when the pump will be like it is working on different flow rate, or you can say at a different head, or you can say and different speed. When the pump is working at different discharge, flow rate, head and speed, then we can find out what is the behavior of the pump and what is the performance of the pump. And these characteristic curves are actually divided into three categories. It is of three types. So what are the three types are? First one is that is main characteristics curve. First one is the main characteristics. First one is the main characteristics curves. And the second one is, that is another parameter, that is operating characteristics. That is operating characteristics curves. And the third one is that is actually Musel's curve, or used to call that is constant efficiency curve. That is actually constant efficiency, or we can say another one name also there for that is Musel curves. Okay, so these are the three different types of curves are there in the characteristics curve. So first one, in this lecture we will discuss only the first one, that is main characteristics curves. So the first one will give the heading of, that is main characteristics curves. So in these actually whether it is in the main characteristics curves or whether it in the operating or constant efficiency curves, we need to consider few parameters. Okay, few parameters which are required in the centrifugal pump. So what are the parameters are basically required? We know that, as I told you, that three parameters already I told you here. Okay, so along with that, some other parameters also there. That means we require the head, basically the head of the place, how much head is there, that where the pump is supposed to work, and what is the speed of the pump, okay, and what is the flow rate or discharge from the pump. Along with that, from this we can able to calculate like what is the power of the pump and what is the efficiency of the pump. So these are the parameters need to be, actually these are parameters are involved in the pump. Okay, so out of these parameters we need to find out some correlations. Actually this is the diagram what I have taken from the book. So this diagram actually indicates for the main characteristics curves. So in this diagram, if you see like these are the parameters which are in the y-axis. This is our suppose y-axis, and in the x-axis it is given speed. So before coming to this diagram, let me give you a small hint about the previous lecture what we have discussed. So in the previous lecture, if you remember, we have discussed about the model testing of centrifugal pump. So during the model testing the centrifugal pump, while discussing about the model testing of centrifugal pump, that means what I mean to say, before going to manufacture an actual pump, we need to create a model, and from that model, that means a small model can be developed or created. From that we need to do the test on the model, then we can go for the prototype, actual prototype. So while discussing this model testing of centrifugal pump, we have discussed some formula, we have identified some relations, correlations. So just I'll give a hint what are the correlations we have found there. So first one, actually that was a specific speed. So we got a correlation on the specific speed now. So the specific speed for actually just I'll give for only one, remaining we can understand. So the specific speed for the model, it should be equal to, we need to consider it should be equal to a specific speed for the prototype. That means when you develop a model, and we need to identify what is the specific speed on that. For the specific speed, what are the other parameters required, that I'll tell you. And this value should be equal to this. Okay, that was given. And here we found that the equation was given like n into root over of q, and we got that is hm to the power 3 by 4. And this one we got there. This is for the model. Similarly, this should be also equal to the prototype. And there we can write this is the constant, suppose some value is there. Okay, and here q is the discharge, hm is the manometric head. Okay, this one we got for this one, specific speed. Okay, so first one, this is specific speed. The second one is, that is we got the one correlation for the head, that is manometric head. So the correlation for the manometric head, we actually we got here, that is root over of hm by dn equal to constant. And this relation of this equation, how I got in the previously, that I already explained the previous lecture, so that you can see that one. You can see the previous lecture, you can understand, or you can remember that this is the correlation what we got previously. Okay, so here I can write shortly. So we know that the tangential velocity, this is pi dn by 60. This correlation we know previously, all I have seen many times. And also we know that the tangential velocity is directly proportional to root over of manometric head. Okay, this one also previously we have seen tangential velocity, that is 2gh. Okay, there h is there, that one. So if you see u equal to this one, u is directly proportional to this one. So here I can write u is directly proportional to dn, because pi is constant, 60 is constant. So if I can write here u is directly proportional to dn and u is proportional to this, then finally what I can write here, I can write hm is directly proportional to dn. And if I write hm is directly proportional to dn, then I can write hm by dn equal to constant. That's what I got here. And the next one more equation what I got previously, that is for the discharge and power. Okay, so for the discharge and power, actually there we got the equation, that is q by dq by n. This is equal to constant. So this is also similar way how I found, like discharge equal to discharge, we know that area into velocity. From that area we can write like d square into n, then again we can write that is on behalf of d square into vf, because area into vf. Okay, and there again vf is directly proportional to u. So by that relation we got finally this equation. Okay, so we won't go that much depth in that equation. If you want to know about this equation how it came, you can see the previous, you can refer the previous lecture. Okay, so what is our basic funda here to understand the characteristics, main characteristics curves for the centrifugal pump. This is the discharge equation what I got. And the last one, another one is there, because if you see in this equation speed is there, discharge is there, head is there. So I got the equation for the head, I got the equation for the discharge. One more equation is there, that is power. So the last one, power equation, there we got the correlation, that is p by d to the power 5 and n to the power q equal to constant. So this is the correlation. So these are the three correlations what we have discussed in our previous lectures, and from that relations, from that equations, this curves are identified. By conducting of number of tests or number of experiments, we finally got this one. So if you see the equation here, like as I told you that we have x-axis, we have the value of speed, and y-axis we are having different values. And these are the plots are identified. The first one, suppose I'll take one curve. Okay, so this is one curve is there. Okay, first suppose this is the curve is there. Now in this curve, if I want to represent, so this curve is, it is given the relation between discharge versus what, speed, correct. So this one I'll give number 1, this is number 2, and this is suppose number 3. So it will be easy for us to explain here. So number 1 is giving, that is q is directly proportional to n. Q is directly proportional to n. That means if your speed is increasing, your velocity, like your discharge also increasing. So that Q and N, that relation, where, which one? This one relation, correct. So diameter is fixed for all these correlations. If you see, the diameter is fixed, because we know that pump diameter of the pipe is will be there. So diameter will be fixed for any kind of conditions. So the diameter we cannot vary that one. Okay, but here if you see this equation, like this from this discharge equation, what is that? Q divided by, this is the equation what we have taken, that is dq by n equal to constant. So here also what I can write, again if I want to write this, so I can write this is dq, and as I told you that this dq d is constant, so what I can write, q is directly proportional to n. That means discharge is directly proportional to speed. The same thing I have written here. So same thing given here also. The q is directly proportional to n. At that condition, our hm should be constant. That means head should be constant here. So what we can explain, like when you consider a relation between the discharge and the speed, there we need to consider the hm is constant. And how we can get this equation? Already from this previous correlation, this one we got this equation. And how this equation structure is? It's showing a linear structure. If you see, this is a linear correlations or linear relations between the discharge and the speed. Now we'll come to the second one. The second one, which is plotted here, that is showing the relations h directly proportional to n square. That means that is the relations of head. So now head, where is the relation? This is the relation of head, this equation. Okay, let me tell you. So this second one is showing the relation between head here. See, in the x-axis, if you see, I'm keeping always the discharge, like speed, that is fixed. So y-axis only parameters are varying. So second one is showing head. Okay, this one is q versus n. Okay, and here this is h versus n. Suppose in that what we got, again h is directly proportional to n square, that is speed square. So how we got, again I'll go to the equation, this second equation. So in the second equation, what is given in the equation what we got here, that is root over of hm by dn equal to constant. Okay, equal to constant. So here if you see, we can write this equation like root over of hm equal to dn. As I told you, this is our constant term, diameter is constant term. So hm, if I want to write hm, I can write this is directly proportional to n square here. Just I'll take this root over out, I'll take and other side I'll make it square, so we can get this relation. That means the manometric head is directly proportional to the square root of square of speed. Okay, now at this condition, what, our discharge need to be taken constant here. One parameter we need to take constant. Okay, otherwise it is not possible. So for the first condition, head was constant. Now here at this condition, what is there? We need to consider q is constant here for the second. And if you see this equation, this relation, like this curve is showing as a parabolic, like because it is, you can see the square is there for this one. So in the first one we got linear, in the linear relations, first one, and second one we are getting this as a parabolic equations, parabolic curve. parabolic curve. Okay. Now we'll come to the third one. So third one is what? Third one is given the relation between power. This is power and speed. So this equation is power versus speed. And in the power versus speed, again, I need to come back to this equation. Correct. In this equation, if you see what is given, again the same thing I can write here. From this equation I can write P equal to d to the power 5 n to the power q. Now as I told you, the diameter, our diameter is fixed, that is constant, so we can write P equal to nq, or else I can write P is directly proportional to nq. Correct. The same thing is given here in this curve. So here also, here written the power is directly proportional to the cube of speed. Okay. Previously head is the directly proportional to speed square. So here power. Now at this condition, in this power condition, we need to keep, because power is the output one. Correct. At this condition, our discharge and head both should be constant here. So here what we need to write, Q and H. Okay, both are constant. Both are constant at this condition. And this curve, actually, if you see this curve, like how it is showing, this curve means actually the P versus N. Okay, this P versus N showing a cubic curve. This is a cubic curve. This is a cubic curve. This is a parabolic curve, and this is our linear. This is our linear. So here the curve we are getting, that is cubic. Okay. So I hope you understand this characteristics of centrifugal pump. Only just 3 things I have given information regarding the previous lecture what we have discussed. Okay. If you know that one, it is well and good, or else you can understand from here like how it is given. So the basically to understand the behavior and the performance of a centrifugal pump. So how we got this one? By conducting number of tests, as I told you, by conducting number of tests on the centrifugal pump with different parameters. So we got this plot, and this plot only that is main characteristics curves. So remaining curves will discuss in our next lecture. I hope you understand. Still, if you are having any kind of doubt and query regarding this, you can give a comment on the comment box. Thank you all.